Hello everyone, welcome to today's class. Today we are going to start with a new topic known as matrix or matrices. Okay, so in matrices, what is done is you arrange, let's say, a matrix. So you arrange some data, let's say 1 2 3 4 5 6. Okay, you arrange this in rows and column. Okay, I'm not saying they has to be on the order. Okay, this sort of arrangement is called matrix. Data arranged in row and column. I can call another matrix as say be let's say random values 1 minus 2 5 3 1 6 4 0 also. Okay, something like this. Square root also, let's say square root here. Okay, square root 3. Fraction, square root, trigonometry, anything can be written inside this. Okay, so when you have the data in rows and column, that's your matrix. All right, now in general we'll represent a matrix like the elements will be A11, A12, A13, A14, A1n. Okay, this is the first row. Second row will be A21, A22, A23, A24, so on, A2n. Okay, not necessarily it has to have only two rows, it can have multiple rows. A31, A32, A33, A34, okay, A3n. All these values A33, A34, there are some numbers, I don't know those numbers, it can be something. Okay, if we keep doing this and let's say there are m rows, so AM1, AM2, AM3, AM4, dot dot dot, AMn. Okay, this is in general representation of any matrix. Okay, which has how many rows? M rows and n columns. Okay, so the order is written as m cross n. Okay, so the first word that we have to understand is order of matrix. Okay. M cross n. Okay, where m represent number of rows and n represent number of columns. Okay, all right. Now each of these values A12, A23, they are called elements. Okay, so I'll put it here, they are called elements. Okay, like in the previous example, like 1 2 3 4 5 6, 1 minus 2 minus 5 4, all these are called elements. Okay, so one particular value at any position, okay, that's element. Okay, if I say what's A23 element, so this one, whatever value present here, that will be A23 element. Now how do we locate that? 2 3 means second row, third column. Okay, so get inside the second row and look for the third element in the second row. Okay, so A32 means a third row, second element. Okay, like this. Okay. If we talk about number of elements, how many elements are there? So the number of elements will be mn. Remember that this is not multiplication, it is represented like this, m cross n. This is not multiplication. Okay, not multiplication. Okay, but the number of elements, if I want to know how many elements are there in this matrix, I have to multiply rows with columns, so m multiplied by n, so that will be represented by mn. Okay, it will give us some value. Like for these, how many rows are there? There are 2 rows, row 1, row 2. How many columns are there? R1, R2. Okay. How many columns are there? C1, C2, C3. So the order is 2 cross 3. But if I talk about number of elements, how many elements are there? So there are 2 multiplied by 3, that's 6 elements. We can count it also, or we know by multiplying order, by multiplying the actual order, we get number of elements, mn. Okay. All right. So any general element or any general matrix will be represented like this. A matrix A will be represented like this: Aij m cross n. Okay. M cross n will tell you the order. Aij tells you it is the elements, whatever the element is. Okay. Aij, I and j are basically from m to n. Okay. So let's say if I is 1 and j is 2. Okay. So that's A12. Okay. The first row, second element in the first row, that's your A12. So any matrix will have elements in m cross n order. Okay. That's the general representation of any matrix. Okay. All right. Now let's see the types of matrices. Okay, the first type that we have to study is column matrix and row matrix. So as the name suggests, column matrix means it has to have only one column. Okay, that's the keyword. Column matrix means only one column. Okay, you can see like this is the example. Okay, values can be anything. If we look at the order, how many rows are there? 4 rows. How many column? Only one column. Of course, it has to have one column only. So any column matrix will have order of m cross 1, because n represents, here general order is m cross n. N represents number of columns. So columns are 1 for column matrix. So n will always be 1. Okay. Column matrix, this is the order. Okay. General representation, I told you how do we generally represent matrix. Aij and then order. Order is m cross 1. All right. Next is your row matrix. So as the name suggests, row matrix have only one row. Columns can be any number. It has to have only one row. So this, how many row? 1. How many column? 4. So 1 cross 4 is the order of this. So in general, okay, now it's not saying A, it is saying B matrix. Okay, the name of matrix can be any alphabet. So B matrix is Bij, that represents elements, and the order is 1 cross n, because it will have always one row. So first is number of rows, then there is number of columns. All right. Let's look at the next type of matrix. Next is square matrix. So square matrix, first of all, it should look like a square. So in square, sides are equal. Here rows and columns are equal. You have 1, 2, 3 rows, you have 1, 2, 3 column. Okay, so in this, the number of rows and number of columns have to be equal. So m should be equal to n. Okay, or number of rows and number of columns are equal, then it's called a square matrix. And since they are equal, they are called square matrix of order n. If the question says that there is a square matrix of order n, it is automatically implied it is n cross n. Okay, like for this, they can say this is the square matrix of order 3. They will not write 3 cross 3, just say square matrix of 3. That automatically implies 3 cross 3. Okay, so it will generally look like a m cross m or n cross n. Okay, the order of matrix m. All right, Next type of matrix, diagonal matrix. Okay, so diagonal matrix, as the name suggests, it should have only the diagonal elements. Okay, all a matrix is said to be diagonal matrix if it has diagonal elements only. Okay, it has, if the non-diagonal elements are 0. I'm saying that it should have only diagonal elements, means rest of the elements should be 0. As such, see, in the square you can have 2 diagonals, but we consider this the forward path, like this one only as the diagonal. We don't consider this as a diagonal. Okay, the green one is not a diagonal of a matrix, this one is only the diagonal. So diagonal matrix is a matrix in which only diagonal elements are there, rest all the elements are 0. Okay, so in general it is defined as see, I'll explain this condition because sometimes it is written like this, so you have to understand what's the meaning of this. It is saying Bij is 0 if I is not equal to j. What does that mean? It implies, say, let's say I is 1 and j is 2, so b12. So if the condition says ki Bij is 0, that means b12 is 0. But what if it is b11? Then we cannot for sure say it's 0, because this condition is true only in the case of I not equal to j. If I say 1 1, okay, this is a11 or b11. Okay, this is B matrix, so let's say b11. Okay, this is c11, this is c22, this is c33. So the diagonal elements, I'll say it has I and j equal. Okay, so all the elements in which I and j are not equal, I can say they are 0. So that is what is written here. Okay, so I'll just put it like this, that diagonal elements, for diagonal elements I is equal to j. For non-diagonal elements I is not equal to j. So when I is not equal to j, we want the non-diagonal elements to be 0. That means Bij should be 0 when I is not equal to j. Okay, again the name, the alphabet B, C, it can be anything. Okay, you have to understand I and j representation. That's pretty standard here. Okay, so this first one is a diagonal matrix of order 1 because it has only one diagonal element. Second one is a diagonal matrix of order 2 because it has 2 diagonal elements. Third one is a diagonal matrix of order 3 because it has 3 diagonal elements. And remember, diagonal matrix is only defined for a square matrix, means it is not defined for a non-square matrix. Means for this 1 2 3 4 5 6, you cannot have diagonal elements in it because it's not a square, it's a rectangle. As such, the shape is kind of a rectangle. Rectangle has diagonals, but in the case of matrix we don't say it has a diagonal elements. Okay, so first of all it has to be a square matrix, then the diagonal elements, all the non-diagonal elements should be 0. Diagonal elements can be anything. Okay, anything means 0 can also be there. It's not a necessary condition it has to be 2, it can 0 be also. It's just that non-diagonal has to be 0. Then scalar matrix. Scalar matrix again is a, first of all it's a diagonal matrix, okay, in which all the diagonal elements has to be equal. Diagonal elements are equal. Diagonal elements are equal. Okay, that's the only definition that you can understand easily. This representation again trying to say the same thing, is just that in a notation way. Okay, if the diagonal elements are equal, just this will help you understand what is a scalar matrix. Okay, again it is saying Bij when I is not equal to j. He is talking about non-diagonal elements. So then they are 0. So first it makes sure that the matrix is diagonal, and then Bij is equal to k when I is j. I is j is diagonal element. He's saying that the diagonal elements are equal to some k. K can be anything, 1, 2, 3, 4, root 3, root 5, anything. But all the diagonal elements are same and they have the value k. Again, same thing. This is also a scalar matrix of order 1. This is scalar matrix of order 2. This is scalar matrix of order 3. Okay. Next, let's see. Yeah, last mostly. No. Lastly, you have identity matrix. Now, identity matrix, again, it is nothing but a scalar matrix, okay, in which all the diagonal elements are 1. Diagonal elements 1, diagonal elements 1, then it is called identity matrix. It's as simple as that. So, same definition, when I is equal to j, means diagonal elements all the diagonal elements have to be 1, it is saying, and I is not equal to j, then they have to be 0. Non-diagonal element should be 0. Okay. Usually it is represented by I, or sometime it is written by I subscript n also. Okay. Now I subscript n implies the order. Okay. So order means, again, if we have only the first order, we say it is I1. If we have a 2 cross 2 identity matrix, it's I2. If we have 3 cross 3 identity matrix, it's I3. Okay. So diagonal elements 1, that's identity matrix. Finally, you have the 0 matrix. Okay. Okay. So 0 matrix, or it is also called null matrix, if all the elements are 0. Okay. 0, 0, 0, 0, 0, 0, 0, like this. It can be of any order. There is no constraint that it has to be a square matrix. It's just that from the diagonal it starts. The diagonal has to be a square matrix. Scalar is also a diagonal matrix, so it has to be square. Identity matrix is also a scalar matrix, so it's also a square matrix. Okay. The representation for this null matrix or 0 matrix is O. Remember, this is not 0, this is O. Okay. The purpose is to say, like, A minus A. If we subtract two similar kind of matrix, we get not 0 but O matrix. Okay. All right. Now comes the condition for equality. How can we say two matrices are equal or not? Okay. Okay. So equality of matrices. So two matrices are said to be equal. First of all, they have to have same order. Okay. Before even making the element same, first they have to be of same order, and then corresponding elements must be equal. Okay. Corresponding element means first row, first element, first row, first element, they have to be same. Second row, second element, second row, second element has to be same. Okay, second row, first element, second row, first element. That was first row, second element, first row, second element. So correspondingly, they have to be same, position wise, I mean. Okay. For this, if you look at this, the first element, first row, first element is not equal to the first row, first element. The moment we see this, we know they are not a equal matrix. So for these, just even if one element doesn't match, we can say that these matrices are not equal. Okay. And we write it like this, equality. Okay. If two matrices are equal, we say A is equal to B. Okay. All right. All right. Now let's see a few questions based on this idea. Okay, let's see some questions now. You have a matrix. This is the matrix that is given. He's saying write the order. So let's see how many rows. 1, 2, 3. 3 rows, 3 cross. How many column? 1, 2, 3, 4. 4 column. 3 cross 4 is the order. He's saying number of elements. Either you can count it or just multiply 4 and 3. 12. He's saying write A13 element. A13. 13 means first row, third element. First, this is R1, first row. Third element is 19. Okay, 19. Then he's saying A21. Second row, first element. 35. Then it says A33. Third row. Okay, this is row 3, row 1, row 2, row 3, third row, third element, 1, 2, 3, minus 5. A24, second row, fourth element, 12. A24 was there, A23 is now, A23 is second row, third element, that's 5 by 2, so 5 by 2, okay. Very easy, very direct questions. Next, it says if a matrix has 24 elements, okay, what is the possible orders it can have? So for second question, let's see. He's saying number of elements, number of elements. That's 24. That's mn. Okay, m into n. Now mn is 24. That means we have to decide what can be the possible values of m and n. So let's see. Something multiplied by something should be 24. What is the possible combinations? It can be, let's start writing. I'll write here. It can be 2 multiplied by 12. Okay, that can also result in 24. So 2 cross 12 can be one order, or it can be the reverse also, 12 cross 2. So we'll just write down the reverse also, because these are two different matrix. 2 cross 12 means 2 rows, 12 column. This means 12 rows, 2 column. Okay, then we can write 6 cross 4, 4 cross 6, that's also 24. 3 also, na? 8 cross 3, 3 cross 8, that is also possible. What else? 24, 1, 2, 3, 4, 5, 6, then we have already done 7, 8. I think that is pretty much covered. But one thing that we missed is we can write 24 cross 1 also, or 1 cross 24 also. Okay, it can be a row matrix or a column matrix also, all 24 elements in one single row. Okay, so what are the possible orders? These are the possible orders. Okay. Second question, I think one part still left. What if the elements were 13? So if the elements were 13, this was first part. The second part says if the number of elements were 13, so 13 can be written in only one way, because 13 is a prime number. So 13 into 1, or 1 cross 13. So for any prime number of elements, you will have always two orders, 1 cross 13, 13 cross 1. Same thing you have to do in the third question. 18 elements are there. Try to write the possible combination. Okay. All right. Third one is for your practice. You can do it on your own. Let's give it a try for this. He's saying construct a 2 cross 2 matrix. So first of all, a 2 cross 2 matrix will look like this. Let's say it's A matrix, okay, with the element Aij, but Aij is given by this rule. So anyway, let's write how many elements are there. 2 cross 2 will have 1 1 1 2 2 1 2 2. Okay, 2 rows 2 column. This is a 2 cross 2 matrix. Now all I need is the value of this 1 1 1 2 2 1 2 2. Okay, now as per the rule given for the first part, I'm doing the first part. Pretty much you can easily do the second and third. Aij is given by I plus j whole square divided by, so for A11, what do we have to do? We have to replace the value of I and j by 1 and 1. So 1 plus 1 whole square divided by 2. So 2 square 4 by 2 2. A12, 1 plus 2 whole square divided by 2. Okay, 1 2 means we have to put I as 1, j as 2. So 1 2 1 3 square 9 by 2. So we can write 4.5 also. Your call. It's not necessary that you have to put in decimals. You can write in decimals or fractions, your call. A1 A21, again same thing. It's just that it will be 2 plus 1 whole square divided by 2. That's again 4.5. And A22, 2 plus 2 whole square divided by 2. That's 4 square 16 by 2 8. So the matrix will be 2 4.5 4.5 8. Okay, we just replace the values. Okay, same way you can do the second part also. Okay, second part is again we have to write down 2 cross 2 matrix. So this time I'm not writing A11 1 2, you know it will be that I by j. So A11, when you put 1 and 1, it will be 1. If you put 1 2, second element is 1 2, A12. So I is 1, j is 2, so 1 by 2. Third element, or this one, second row first element, A21, I is 2, j is 1. Okay, so I is 2, j is 1, 2 by 1 2. And lastly A22, put I as 2, j as 2, 2 by 2 is also 1. Okay, so 2 parts I've already done. This one you can practice. Okay. All right, now what they can do is they can modify these rules, they can modify the order, and you'll have to find accordingly the matrix. Let's see how the equality of matrix is used in questions. Look at this question. He's saying find the value of x, y, z. So for this matrix, if it is equality is written, that means corresponding elements must be equal. So the first element should be equal to the first element. So I can say directly that y is 4. The first row second element should be equal to, let me change the first row second element should be equal to, so z is 3. Okay, and if we take one more, second row first element, they must be equal, so x has to be 1. Okay, now I'm not going to highlight it, I'm just going to use it directly for the second part. Okay, so for the second part, x plus y, the first element should be equal to 6, so I get one equation, x plus y equal to 6. Okay, we cannot solve it right now. Second element 2 2 already matching. Second row first element 5 plus z is 5, so 5 plus z is equal to 5. That gives me z as 0. I got the value of z. This was the first equation. And lastly you have xy as 8. Okay, so xy is equal to 8. if we use the first equation and the second equation, we have to solve it now. Okay, although it's very obvious. You add two numbers, you get 6. You multiply two numbers, you get 8. Okay, so what is the possible combination? 2 4, 4 2 or 2 4. Okay, but if you want to properly solve this, get the value of y as 8 by x, put it in the first equation, and then solve. X plus 8 by x is equal to 6. Solve it. You'll get the two values of x as 4 and 2. Similarly, accordingly, you will get y as 2 and 4. If x is 2, y is 4. If x is 2, y is 4. Lastly, same idea. It's just that solving it can sometimes be slightly tricky. So I'll give you the tip. X plus y plus z. They are all column matrix. So the first element should be first, second element should be equal to second, third element should be here third. X plus y plus z is equal to 9. That's our first equation. We cannot solve anything about it. The second equation is x plus z is equal to 5. Again, no direct solution right now also. Y plus z is equal to 7. Again, no direct solution. Now, in order to solve this, what I'll do is I'll just add these two, second and third. Okay, only these two. If I add them, what do I get? X plus y plus z plus z. So I'll write z plus z, not 2z. You'll see why. 7 plus 5 is 12. I know x plus y plus z is 9, so I'll replace it here. So 9 plus z is equal to 12. I get z is equal to 12 minus 9, that's 3. Once I get the value of z, I can now get x by putting in this second equation. So we get x as 2. If I put it here, I'll get y as 4. Okay. All right. So equality can be generated. Equality can be used to generate equations, and then you can solve those equations accordingly. Okay. Now one question that is interesting here. See, matrices as such is a very simple topic, but again it can be easily combined with something else like trigonometry, or as in this case, one of the good question that I like, PNC. Okay, because he's asking for number of possible matrices. He's saying you have a 3 cross 3 matrix. Okay, fine. 3 cross 3 matrix, that means A11, 1 2 1 3, 2 1 2 2 2 3, 3 1 3 2 3 3, like that. Okay, he's saying each entry can be 0 or 1. Okay, so you can have 0 or 1 here, 0 or 1 here, 0 or 1 here, and so on accordingly for all the possible positions. He's saying how many such matrices are possible. So point is, if you have gone through PNC lectures, you can easily understand this. This is nothing but dash method, because I've drawn dash, because two possible values can come here, two possible values can come here also, because there is no constraint how many zeros or 1 we can use. Okay, so 2 2 2 2 2 2 and 2 2 2. What do we do with this? We multiply all 2. So 2 multiplied by 2 multiplied by 2, keep on multiplying, but you get 2 raised to power 9. That's 512, option number D. If I want to modify this question, what I'll do is, let's change the order also. If order is 2 cross 3 and possible, each entry can be -1 0 1. Then number of such number of possible matrix. How many possible matrices are there? Try to solve it. So 2 cross 3. First of all, you roughly draw 2 cross 3. 2 rows, 3 columns. So 3 entry in each row. Each can have 3 possible options: -1, 0, and 1. 3 3 3 3 3 3. Just multiply them. So answer is 3 raised to power 6. Okay. All right. Next, let's talk about addition, subtraction of matrices. Okay. So what I'll do is I'll just give you one question to explain how does addition subtraction works. That's it. Okay. Okay. Actually, everything will be pretty much covered here. All the operations that I have to teach will be covered in this question. So first we'll talk about addition and subtraction together. See, addition and subtraction are possible only for same order of the matrix. If the matrices don't have the same order, you cannot add, you cannot subtract. So it is applicable only for the same order matrices. Okay, which A, B, C all are. They all are of 2 cross 2, 2 cross 2. This is also for 2 cross 2. Now if we want to add them, we'll add them correspondingly. So only the keyword here is for addition add, for subtraction subtract, but correspondingly. What does correspondingly imply? Means each value will be added correspondingly. Each value will be added or subtracted as per the position. Means the first element will be added to the first one, first row second element will be added to first row second element. Okay. The second row first element will be added to second, and the second row last element will be added or subtracted to the last. Okay, like this. That's the meaning of correspondingly. Okay, so A plus B will be, add them 2 with 1, or let's copy paste 2 4 3 2 plus 1 3 minus 2 5. If we are adding them, add them correspondingly. 2 plus 1 3 4 3 7, 3 minus 2 is 1, 5 plus 2 is 7. Okay, A minus B, same idea, add and subtract them also correspondingly. So when we subtract, so 2 minus 1 1, 4 minus 3 also 1, 3 minus minus 2, that's 5, 2 minus 5 is minus 3. Okay, so now we have understood how to add and subtract. First of all, they have to be of same order, then only we can do addition and subtraction, and they have to be added or subtracted correspondingly. Okay, position wise. Next is 3a minus c. Now next we have to understand multiplication by scalar. Multiplication by scalar. So if your A matrix was 2 4 3 2, if we suppose we are multiplying A matrix with 3, that's represented by 3a. So point is 3 is multiplied with this matrix 2 4 3 2. How do we multiply a scalar number with a matrix? Basically what we do, we multiply each element with 3. Each element will be multiplied by 3. That means it will be 6, 4 3s are 12, 3 3s are 9, 3 2s are 6. And then you have to solve 3a minus c. So 3a matrix, you know, 6, 12, 9, 6 minus, what was your c matrix? Minus 2, 5, 3, 4. Minus 2, 5, 3, 4. Okay. So 6 minus minus 2, that's 8. 12 minus 5 is 7. 9 minus 3 is 6. 6 minus 4 is 2. Okay. Done. All right. 9 minus 3 is 6. 6 minus 4 is 2. Okay. The next thing that we have to understand is multiplication of matrix, and this is the last operation of matrix that you have to understand, because there is no such thing as division of matrix. There is only multiplication of matrix. So multiplication of matrices. All right. AB needs to be multiplied, BA needs to be multiplied. First of all, for addition and subtraction, I told you that they have to be of same order. For multiplication, that's not the criteria, and we'll not do this example first. We'll do some other example. Okay. Let's say you have a matrix M cross N. Let's say you have a B matrix P cross Q. So AB can exist. There is a possibility it may not. Okay. So AB can exist only if, what if these two are equal. Okay. So put a equal to here. I'm noting equal to here. If only number of columns of A matrix equal to number of rows of B matrix, but I don't have the tendency to learn it like that, because we have to write AB. I'll write their order, and whatever is present inside N and P, they must be equal. So N is equal to P. Don't try to learn this condition, just write them and see if the middle values, okay, whatever the present in the middle, they must be equal. If they are equal, then only AB can exist. Okay. And see, AB is also a matrix, so it has to have an order, and order of AB. Now what is order of AB? So order of AB will be what is left, M and Q. So whatever left is your order of AB. M cross Q will be the order. Okay. Let's see for BA. Okay. Let's see what will be the condition on BA. If B is P cross Q, A is M cross N. So in order for BA to exist, BA can exist only if what is present in the middle? In the middle, Q and M are present, so they must be equal. Okay, so Q is equal to M, and what will be the order of BA? That's remaining is P here, remaining is N here, so P cross N. Okay. So don't try to learn these conditions, try to understand how they are being executed here. Okay. Now that we know that if some matrix can be multiplied or not, let's see how actually the multiplication will take place. So let me get one example here. For multiplication. This is okay. We'll do both parts. Okay. Also remember, this is not algebra. So BA and AB, they may or may not be equal. Okay. Even after multiplication, it's not a condition that BA and AB will be equal. They will not. They may or may not be equal. Sometimes they may. I'm not saying for sure they will never be equal. They can be. Now we have to multiply. So let's see, first of all, is the condition valid here? It is 2 cross 3. That's 3 cross 2. So whatever is present inside here, they are equal. So yes, the multiplication is possible. AB is possible. Okay. Let me rewrite that. A is 2 cross 3. B is 3 cross 2. So the inside 3 and 3 are equal. So yes, multiplication is possible. So AB exists. So, and it will be of order. Remaining is 2 cross 2. AB exists. Now in order to multiply AB, 2 cross 2 na, you multiply first row with first column again correspondingly. Okay, this is something that you have to understand through example, because the theoretical sense, even if I try to give it to you, it will be very complicated. So you have to multiply first row with first column correspondingly. That means this 1 will be multiplied with this 2, this minus 2 will be multiplied with 4, and 3 multiplied by 2, and add them. Okay, so 1 into 2 plus minus 2 into 4 plus, we'll need more space, okay, plus 3 into 2. That's your first element only. Then you do the same thing for second column. First complete multiply with your first row with first column, first row with second column. Okay, so 1 multiplied by 3 first with first, plus minus 2 multiplied by 5 plus 3 multiplied by 1. Okay, same thing then you have to do with the second row. Now repeat the same process. Second row, first column. So minus 4 2 plus 2 4 plus 5 2. Here minus 4 3 plus 2 5 plus 5 1. Then solve. This is 2 minus 8 plus 6, that's 3 minus 10 plus 3. This is minus 8 plus 8 plus 10, that's minus 12 plus 10 plus 5. That's 0. This is coming minus 10, not minus 10, 6 minus 10 minus 4. This is coming 10. This is coming 15 minus 12, 3. So that's your AB, 2 cross 2. Okay, 0 minus 4, 10 3. Okay, all right. So again, repeating the whole idea. Multiply first row with first column correspondingly and add the result. First row then with second column, second element, then start with second row, first column, second row, second column. Okay, all right, let's do BA now. So for BA, I'll recommend that you write B matrix first. BA, the B matrix is 2 5 4 5 2 1. A matrix is 1 minus 2 3 4 2, sorry, minus 4 it was. I did consider minus. Okay, minus 4 2 5. Okay, let's see if the multiplication is possible. This is 3 cross 2, this is 2 cross 3. Middle things are equal. Yes, possible. So the result will be a 3 cross 3 matrix. Let's see. First row, first column correspondingly. So this time I'm going to do directly 2 into 1, 2 minus 20 minus 18. Okay, then first row with second column. Okay, so 2 into 2 minus 4 plus 10, minus 4 plus 10, you will get 6, then 6, 2 into 3 6, plus 5 5 25, 31. Okay, 31, one second, 5 5 25, 3 to 6. Have I copied it correct? Okay, one second. 2 3, my bad, I copied the matrix wrong. This was 2 3, that means let me check the first calculations also now again. So 2 and minus 12, I think everything will be changed accordingly now. So let me restart. So be very careful while copying the data itself. Okay, so 2 into 1, 2 minus 12, you'll get minus 10, then minus 4 plus 6, you'll get 2, then 3 to 6 plus 15, 21. Then do it same thing with the second row, first column, 4 into 1, 4 minus 20, so minus 16, then minus 8 plus 10, you'll get 2, then 12 plus 25, 27, 37. Okay, then 2 multiplied by this minus 8, 2 multiplied by 1, 2, and minus 4, so minus 2. Then second element, 2 minus 2, 4, minus 4, and plus 2, minus 2. And lastly 3 to 6 plus 5, 11, minus 2 minus 2, 11. Alright, that's your 3 cross 3 matrix of BA. Okay, so this is how you multiply your matrices, row with column correspondingly. That will give you only one element, so you have to be careful how to go about that. All right, and clearly you can see your BA is a 3 cross 3 matrix. Earlier we calculated AB, that was a 2 cross 2 matrix. The order itself is not same, so how can the matrices be same? So yes, they cannot be. AB and BA, they may or may not be equal. Okay, so we have to see accordingly. All right, then let's see some questions now with scalar and multiplication of matrix. Let's look at this question. Okay, one second. You have to simplify this. Okay, so let's simplify. Right now it's written like this, so consider this to be a scalar. Whatever is written outside the matrix, like 2 3 or some trigonometry also, I told you that trigono can also be included in this. Okay, so cos will, each term will be multiplied with cos, so cos square theta, cos theta sin theta, minus sin theta cos theta. This will be again cos square theta, plus you have another matrix, multiply each term by sin, sin square theta minus cos theta sin theta. This one will be sin theta cos theta. Lastly it will be sin into sin, sin square theta. Now you add them correspondingly, first element with first. Okay, so cos, my bad, it's not working, one second. Okay, cos square with sine square. We have to add correspondingly. Second element with second, third one with third, fourth one with fourth. Okay, so cos square plus sine square is 1, trigonometric property. Plus cos theta sine theta minus cos theta sine theta 0, minus sine theta cos theta plus sine theta cos theta again 0, cos square plus sine square again 1. So this is what identity matrix of second order I2. Okay, they can give you in the option like this, or they can give you I1 I2 or something like this, combination of I. Okay, this is done, this is done. Okay, let's look at one question. Okay, you can use the concept of linear equations also in the algebra to get the matrices, for this question. X plus y matrix is given as this, x minus y matrix is given as this. So use the concept like this: x plus y 7 0 2 5, x minus y 3 0 0 3. How we used to solve these equations? Just add them. Y will cancel. This will become 2 multiplied by your matrix X is, add them correspondingly now, 7 3 10 0, this will become 2, this will become 5 plus 3 8. So 2 is being multiplied, take it on the other side, it will become divide. Divide means basically it will become 1 by 2 of this matrix, 10 2 0 8. That means multiply each term with half. So basically 5 0 1 4. Okay, how do you get your y? You can put this in any equation and solve accordingly. So if I put it in the first equation, like x plus this matrix 5 0 1 4 is equal to 7 0 2 5. Take this matrix on the other side, same concept of algebra. So it will be 7 0 2 5 minus 5 0 1 4 and subtract them correspondingly. I did mistake, one second. This was x now, so that means we put it in the first equation. So x plus y plus x, luckily saved. So y matrix will be, subtract them, 2 0, 2 minus 1 is 1, 5 minus 1 is 1. 7 0 2 5, yeah, subtracted 3 0 0 3, correct. Okay, done. All right, now you can multiply the same matrix with itself. Okay, so I'll tell you square of a matrix. What is the meaning of that? It's like square of a matrix, that's a square. Okay, so a square is nothing but a multiplied with a. So whatever your matrix is, just multiply them by writing twice and you will get a square. So as such, there is no too much complex idea about this. Just multiply the matrix with itself. You know, you have seen the concept of multiplication. Solve accordingly. Okay. All right, that was the concept regarding addition, subtraction, multiplication of the matrices. Now let's look at one more thing known as transpose of a matrix. Transpose of a matrix. transpose of matrix, I'll write it. It is represented by A transpose or A dash. Okay. All right. Now, first of all, what happens with A transpose? A transpose. In order to get the A transpose, just change rows to column, or change column to row. Okay, this is how you get transpose of a matrix. Let me put up one example. Let's say A was A, B, C 1, 2, 3, like this, random values. The order is right now 2 cross 3. If we change the rows to column, the first row will be written in first column, so ABC will be written like this, ABC. Second row will be written in second column, so 1, 2, 3. Interestingly, what do you see? That the order also changes. So when you do transpose, the order changes. Okay, so the conclusion is, if A is M cross N, then A transpose is N cross M. The order gets reversed. Okay. Now let's look at some properties of transpose. Properties of transpose. So if you do transpose 2 times, A transpose transpose, you will get the matrix back. Okay, changing rows to column, then again column to rows, you will get back the matrix. If a scalar is being multiplied, you can take it outside and then calculate the transpose of A. Okay, your transpose can be splitted about plus as well as your minus. Okay, we can do A plus B whole transpose, or we can do A transpose B transpose separately. Both mean same thing. It's just that in multiplication, if you have to do AB whole transpose, you have to change the order B transpose, A transpose. And note down one more thing, that if you have suppose ABC transpose, then the order will again get changed, C transpose, B transpose, A transpose. This is the only property with slight variation in it. Rest everything you can understand. Okay. That was regarding transpose. That's it. Next comes symmetric and skew symmetric matrix. Symmetric and skew symmetric matrix. All right, for a symmetric matrix, what happens is your A transpose, one second, but yeah, for symmetric matrix, A transpose is same as the original matrix A, whereas in the case of skew symmetric, that's the definition. Okay, if transpose of a matrix is equal to the same matrix, it's symmetric matrix. If transpose of any matrix is equal to negative of A matrix, means minus 1 multiplied by your matrix. Okay, each element being put it with a negative sign. That's it. Okay, now for symmetric matrix, your Aij element should be equal to your Aj element. I'll explain this with the example, what is the representation means actually. and for this Aij element should be negative of Aji. Okay. Here one more thing is that the diagonal elements are 0. All the diagonal elements have to be 0. Okay. Now let's see example of a symmetric matrix. Example. One, two, three, 4, 5, 2, 3, minus 2, like this. If you do the transpose of this, okay, try to take transpose. If this is A, do the A transpose. The first row you write down as first column. Okay. So 1, 2, 3. Second row 2, 4, minus 2, 2, 4, minus 2 as a column. Third row 3, minus 2, 5, 3, minus 2, 5 as a column. You see A transpose is also same as this. Okay, this is the example. I have verified it also. Now look at the elements at this particular position. This one. What is this? A21. Sorry, this is A12, this is A21. They are equal. Okay. Look at these elements. This is A13, this is A31. They are equal. So Aij and Aji, they are equal. That's the meaning of this. Okay. Aij, Aji. Okay. Look at this element. A23, A32. Okay, they are equal. That's the point. You can judge by this also. Like for 3 cross 3 is a symmetric or skew symmetric by this. Okay. Or you can take a transpose and then see if it is coming equal or not. Okay. All right. Now let's see the example of a skew symmetric matrix. So for a skew symmetric matrix, first of all, the diagonal is 0, 0, 0, 0. Let's write down 2, minus 2, 3, minus 3, 5, minus 5. Okay, if that's your A matrix, that's your A matrix. Calculate your A transpose. Write them down column wise. Row will become column. So 0, 2, minus 3, minus 2, 0, minus 5. Third row is 3, 5, 0. So 3, 5, 0 column wise. And multiply it with the negative signs. So change the sign of every term. Negative becomes positive, positive becomes negative. This is negative, this is negative, this is positive, this is positive. Is it matching now? This is minus A now. Now you have done the transpose as well as you have multiplied with minus 1. Okay, that's minus A dash. So you can see again they are equal. A transpose is same as minus A. Or the same idea, you can directly judge also, like this A21, A12, they must be equal. This A13, A31, they must be equal. Okay. This A23, A32, they must be equal. Okay. This is how can you do assess directly, or you can take transpose also to judge. Okay. All right. Okay. One more thing. It's not necessary that every matrix has to be symmetric or skew symmetric. A matrix can be in category of neither two. Okay, it can neither be symmetric nor skew symmetric. So let's say any matrix A is there. I can rewrite this as sum of symmetric and skew symmetric matrix. Okay, any matrix A can be written as a sum of symmetric and skew symmetric matrix. Let's say P is the symmetric part plus Q is the skew symmetric part. So P is given by half of A plus A transpose and Q is given as half of A minus A transpose. Okay, so any matrix A can be broken down as a symmetric and skew symmetric matrix, where symmetric part is half of A plus A dash, skew symmetric is half of A minus A dash. Okay, let's prove also. Let's prove that A plus A. How do I know that A plus A is symmetric? So let's see. Prove that A plus A transpose is symmetric. A plus A transpose is symmetric. Okay. In order to do that, let's consider, let C is a matrix which is A plus A transpose. If I have to prove that A plus A transpose is symmetric, that means I have to prove C is symmetric. For that, let's calculate C dash. C dash will be A plus A transpose whole transpose. Transpose can be splitted about the addition and subtraction. So A dash plus A dash dash. That's A dash plus A. Is it the same matrix C? So I have proved C dash is equal to C. So definitely I can say therefore it's symmetric. Okay. Same way you can prove A minus A dash is also skew symmetric. Prove that A minus A dash is skew symmetric. Okay. Same thing, let C is A minus A dash. Okay. Let's calculate C dash. So A minus A dash dash, split it about negative also. A dash minus A dash dash. That's A dash minus A. Take negative common, you will get A minus A dash. That's minus C. So I have proved C dash is equal to minus C. So that's why it is skew symmetric. Okay. So you can check whether any matrix is symmetric or skew symmetric, not just by getting the value of the exact matrix, or you can judge it by this concept also. Okay. Like for this question, you can get these kinds of questions also. If A and B are symmetric matrix of same order, then AB minus BA is, now you have to choose the correct option. For that, you have to check. First of all, A and B are symmetric. That means A dash is A and B dash is B. Now, let C is AB minus BA, and we don't know whether it is symmetric and skew symmetric or zero or identity. So let's check from the first two options. First of C dash, AB minus BA dash. It can be splitted about plus minus. So AB dash minus BA dash. Now use the property of distribution regarding multiplication. When you do AB dash, that's B dash A dash minus, this will become, reverse the order, A dash B dash. If this is your first statement, using this I can replace A dash with A, B dash with B, because they are symmetric. So BA minus AB. It is coming BA minus AB, take negative common, so AB minus BA. AB minus BA was our C, so somehow we have proved C dash is minus C, therefore skew symmetric is the answer. So this is the answer for it's a skew symmetric matrix. Okay. All right. We have done now symmetric, skew symmetric. Okay. All right. I think that's it. Rest we'll try to cover in the determinants. Whatever concepts are there, the remaining concepts of matrices evolve around determinants, so we'll continue that in determinant. Now that's it for matrices. This chapter is done. Okay, see you in the next class. Good day everyone. Bye.